Alright, now we're going to be dividing polynomials. We haven't had this, and it is an important rule, and it might look similar to another one, but maybe a little bit different as to what you have to do. I'm going to first expand these for you to see what's going on. This is 2 raised to the 8th. In the denominator, 2 to the 4th. And if you remember, if I have like factors in numerator and denominator, they divide each other out because I get 1. So all I'm left with is 2 to the 4th. Notice my largest exponent is on top. So in the quotient rule, I subtract top exponent minus bottom. I subtract them. So in this one, if I subtract, I've got 13 on top, 3 on the bottom. I'm going to have x to the 10th. In this one, be careful. This is understood to be a 1, so that'd be y to the 14th. So remember, you have your product rule. And you also have your power rule. If you sort of get the rules confused, expand and go back and do your math. So that's the quotient rule. 0 exponent rule. I've been talking about this. Anytime you have a base raised to the 0 power, it equals 1. But you've got to be careful. Of course, there's some sneaky things. So 7 to the 0 will give me 1. Check that on your calculator. A negative 5 in parentheses to the 0 is equal to 1. This looks similar, but it is different because I don't have parentheses. This is considered a negative 1 times 5 to the 0. And in this case, I'm going to have a negative 1. So understanding when you use parentheses and when you don't, what happens, is necessary. This one in a way is sort of similar to this one because I do not have parentheses. I've got 10 times x to the 0. Well, that would be 10 times 1, so my answer here would be 10. This one, if I use my power rule, I'd have 10 to the 0 times x to the 0, so that would be 1 equals 1 times 1, excuse me, and 1 times 1 is 1. So beware of parentheses. They're sort of sneaky. You just have to remember what you have to do with them depending on the situation. Alright. Quotients to powers. Well, the other one was just a product to powers, but in this one, anytime you have parentheses, and this goes for these guys too. I've got parentheses. The exponent is distributed through to everyone on the inside of that parentheses. So when a quotient is raised to a power, raise the numerator to the power and divide by the denominator to the power. So using the quotient to powers rule, it says to simplify each expression using the quotients to powers. I'm going to do the first one, and I'm going to let you do the rest of them. 4 squared. But anytime you have a numerical base, go ahead and find out what it is. So pause me. I want you to do the rest of these all the way down to the C, because you can do those. So 2 times 3, that would be x to the 6th over 5 to the 3rd. So x to the 6th over 125. Don't watch out here, because everything in the parentheses gets raised to that power. So I've got 2 to the 5th, a to the 15th, b to the 20th. I do have a numerical base. 2 to the 5th, check me, it should be 32. So that would be my final answer. So this one, when we're dividing, I got negative 12 divided by 4, that would give me a negative 3. X to the 8th over x squared, I subtract, I have x to the 6th. This one, notice which way you have to divide. I am going to end up with 4 in the denominator, because 2 will go into 8 because you're canceling like factors. But if I go x to the third minus 3, that'd be x to the 0. It's just 1. But if I have something in the denominator, I do need something in my numerator. So that one's just 1/4, which is what 2/8 is. Let's see this one. 15 divided by 3 would give me 5. X to the third, y to the third, because I'm subtracting my exponents. So this is when you have a monomial divided by a monomial, but what if you have polynomials divided by a monomial? Well, we have to get it back to something that we know. First, let me rewrite this in this form. And what I meant by getting it back to a form that we know, we only can do a monomial divided by a monomial. So every one of these, because they are in the numerator, they're getting divided by this 4x squared. And I always go ahead and determine my signs. I'm going to have a negative divided by a positive, so I'm going to have a negative there. So now we're back playing with what we did earlier. So I'm going to have a negative 3 x to the 6th plus my 4's eliminate. I get a 1 there. That would be x to the 4th, a negative 2x. So that would be the answer to that problem. So pause me and do the rest of these and see if you come up with what I'm going to end up with. I think I need to write smaller. Oops. One at a time. Leave the fraction. It doesn't go evenly. If you went 4.5, I'd give it to you, but you don't have to. And the x stays in the numerator. So that would be fine. Or if you had this, as long as the fraction ends and it does not continue, I'll take that as well. This one. So I know that I'm going to have to put this under all of these, so I'm going to try and skip that step right there. And do them individually. 5x cubed y cubed minus. So hopefully you ended up with that. And that'll be it for this one. Thank you.